Integer function just automatically rounded down to the closest integer. In other words, if x was 1.2, it'd round down to 1. If x was 1.3, it'd round down to 1, blah, 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 blah. Now we're just going to take that and divide it by x. So we're going to, this is going to, it's going to be interesting to see. So let's graph it first. So we're going to come in here. You go to second catalog, and then to get to the i's, it is it the x squared button? Yeah. Then you just scroll down till you get to int. There it is. And plug in x, close my parentheses, divide by x, and let's see what we got. Graph it. Goofy. And so what we want to look at, let's graph this on the paper. There's some, well, x can equal 0, right? We all know that.
Yeah.
Right? So we've really got a vertical asymptote on the y-axis because x can equal 0. And there's some, if I zoom in, man, there's some goofy business going on there. Let's look at this. All right, there's some goofy business going on, but it looks kind of like maybe, it looks maybe like, it looks like a step function. I'm going to zoom in a little more to kind of get a better, well, let me just set the window. I'm going to go from -5 to 5, and let's see what that looks like. Yeah. So this function looks really goofy right here. It looks like a step function still, but it's weird. Okay. But if I hit trace, I've got this funny looking graph that kind of looks like this, and then I've got like some business here. Well, this is telling me to look at this function as it approaches 0 from negative infinity. So that means I want to study this behavior here and see what I get. So what I could do is if I just hit trace and I come from negative infinity, which means I start from the left and go towards the right, it does some goofy stuff. It like goes up and down, and then it looks like it might approach infinity, right?
Yeah.
It looks like it might. Now it says you could also do this on the table of values. So if I plug in a second graph, it'll pull up the table of values. And as x approaches 0 from the negative direction, see how it looks like it's going to 1, going to 1, going to 1? Okay, so let's fine tune that. So if I hit second window, that gets me to the table. Let's put in some decimals and see what we get. So if I plug in negative, and we want to get really, really close to 0. So I'm going to plug in like 3 zeros and a 1, and then I want to increment by 0.4 zeros and a 1. Now I'm going to look at the table again. What do you notice about those values as they get closer to 0? Bless you.
They're really big.
They're really increasing, right? In fact, right before I get to 0, it gets really big. So I can only assume, based on the graph and the table of values, that this blows up to infinity in the y direction. Okay? Does that make sense? Does that help you guys?
Mr. Adams,
Yes, sir.
is the int function supposed to be the integer part of the number?
Yeah.
The calculator does a floor, so it's like if you put int negative.
Right, but that is the integer function. So it's a floor function that gives you an integer. Yeah, you're right. It's a floor function, but it gives you the integer. That's what they call it. It's called an integer function, and you could have an integer function that gives you a ceiling, right? So the integer function is a floor step function that yields only the integer. You can have floor functions that are bounded, and floor functions and ceiling functions you can change the parameters of those. But the integer function does give you the floor integer. So we could, yeah, if we were to plug in a floor function, it's the same as the integer function, right? Yeah. But then we're dividing it by x. That was good. That's good. I'm glad that you noticed that. I thought I said that though when we, or no, we covered